It began quietly, almost invisibly, in the early hours of November the 2nd, 2025. The sky was clear over the southern hemisphere, a calm ocean of darkness before dawn, when a small point of light crossed the edge of an astronomical field that few eyes ever see directly. To the world, it was an ordinary morning. But to one man, watching from the Crimean Observatory, it was the return of a mystery he had once already uncovered. His name, Gennady Borisov, the same astronomer who, in 2019, revealed the first confirmed interstellar comet ever observed by humanity. A visitor from beyond the sun's reach. Now, 6 years later, his telescope had captured something new. Another faint traveler, moving on a path that defied everything we thought we knew about the solar system's borders. Its catalog name would later appear in small, understated text across the Minor Planet Center database, C2025 V1 Borisov. At first it seemed routine, a speck against the background of countless stars. Yet as the data came in, a pattern emerged that froze astronomers in the quiet pulse of their instruments. The orbit was tilted, not slightly, but sharply, by more than 113 degrees, almost perpendicular to the plane in which the planets travel. Its eccentricity, 1.095, placed it dangerously close to the definition of a body unbound by the sun's gravity. A single number that whispered of infinity. In simple terms, Borisov's new discovery might not belong to our system at all. The announcement, when it came, was almost secretive. No press conference, no televised excitement. Just a line of coordinates quietly published on NASA's Jet Propulsion Laboratory catalog, mirrored on the websites of the Minor Planet Center and a few observatories that monitor the far reaches of the sky. But those who understood what they were seeing felt a sudden pulse of awe. This object was not behaving as a comet should. It showed no luminous tail, no sublimation glow, no signs of ice turning to vapor under sunlight. For an object racing through space at tens of kilometers per second, that was more than odd. It was unnatural. And so began the murmurs. Could C2025 V1 be a dormant frozen fragment, a remnant of interstellar debris that has long since lost its volatile heart? Or could it be something stranger, something that challenges even the language of our astrophysical models? Preliminary simulations placed its origin far beyond the planets, perhaps from the distant shell of the Oort cloud, a region never observed directly, but believed to cradle billions of icy bodies, ancient and untouched since the birth of the solar system. Yet the same models also hinted that the trajectory, though hyperbolic in appearance, might eventually curve back into an elongated ellipse, as if the object, after a long exile, were coming home. But there was another detail, one that cast a shadow of mystery across the entire event: the timing. Borisov's discovery came just days after another celestial visitor, the interstellar body known as 3I Atlas, reached its perihelion, the point of closest approach to the Sun. Two objects, both without tails, both on anomalous trajectories, crossing the solar system within weeks of each other. The statistical odds of such coincidence were infinitesimal. And yet, here they were. One, a confirmed interstellar traveler, the other, a possible return from the frozen limits of the Sun's domain. Two lines of motion, almost perpendicular, intersecting in space like the silent arms of a cosmic compass. As data poured in, observatories across the world, Pan-STARRS in Hawaii, the Vera Rubin Observatory in Chile, the network at JPL turned their instruments toward the faint light of Borisov's new find. They measured, recalculated, adjusted for gravitational perturbations. Jupiter's massive influence was considered, as even the giant planet's faintest tug can shift the path of a comet across millions of kilometers. But the numbers refused to align neatly. The geometry remained peculiar, almost deliberate, as if the cosmos itself had drawn these trajectories with a purpose only it could understand. And through all this, Gennady Borisov remained a quiet figure, a man whose telescope had twice glimpsed the impossible. In 2019, his discovery told us that the space between stars is not empty. In 2025, it seemed to whisper that this emptiness might, in fact, be watching us back. For C2025 V1 was not just another rock, not another frozen relic. It was a sign, a clue, that our solar system might be less isolated than we believed. The sky above us, it seemed, had decided to speak again. The question was, would we understand what it was trying to say? And so, the world waited. Telescopes followed the faint object as it moved across the blackness, silent and cold, reflecting sunlight without revealing its nature. Scientists exchanged data, cautious but electrified by a sense of déjà vu. Had the same man truly found two messengers from beyond the stars, or was there something deeper at play? Some hidden pattern woven through the mathematics of celestial mechanics. For now, the answers remained locked in the object's faint glimmer. And yet, beneath the analytical calm of scientific reports, a quiet tension began to rise. A recognition that something in the cosmos had shifted. That maybe, for the first time in centuries, we were witnessing not a coincidence, but a convergence. It was, after all, how every great discovery begins, with a question that refuses to fade, and a silence vast enough to hold the universe's reply. The first detailed analyses of C2025 V1 Borisov began within hours after its confirmation appeared in the databases of the Minor Planet Center. At first, the discovery seemed like a fascinating but manageable anomaly, an unusual trajectory, an unfamiliar orientation of its orbital plane, perhaps the result of a gravitational encounter somewhere in the outer regions of the solar system. Yet as soon as scientists began modeling its motion more precisely, it became clear that this was no ordinary comet. The orbital inclination of more than 113 degrees meant that it was moving almost at a right angle to the planetary disk, slicing through the solar system like a needle through cloth. Its eccentricity, measured at 1.095, placed it on the very border between a bound orbit and one that would carry it forever into interstellar space. Astronomers from the Jet Propulsion Laboratory, the Harvard-Smithsonian Center for Astrophysics, and the Max Planck Institute for Astronomy collaborated to verify the parameters. Their combined data confirmed what Borisov himself suspected. This was a body on a hyperbolic trajectory, possibly unbound from the Sun. Its closest approach would occur in mid-December of 2025, at a distance of roughly 269 million kilometers from Earth, close enough to allow continuous observation by major observatories and even amateur astronomers equipped with high-sensitivity cameras. Yet what puzzled everyone was not where it was going, but what it refused to do. Despite approaching the Sun, C2025 V1 showed no increase in brightness, no emission lines, no evidence of sublimating ice. It remained inert, a silent wanderer reflecting sunlight with an almost metallic steadiness. For comets, the lack of activity near the Sun is profoundly unusual. When icy nuclei heat up, they release gas and dust that form the characteristic tail, a luminous signature of their composition. Borisov's first interstellar discovery, I Borisov, had displayed such behavior vividly in 2019, revealing the volatile materials carried across interstellar space. But this new object was different. Its light curve was steady, its color neutral, and its spectrum nearly featureless. The object was, in the literal sense, a dark traveler. No tail, no coma, no cry of vapor announcing its arrival. As the first measurements of its reflectance spectrum came in from the European Southern Observatory's Very Large Telescope, researchers were astonished to find that the object's surface seemed to reflect more blue light than expected for a carbon-rich body. The albedo was higher than that of typical comets or asteroids, suggesting a surface perhaps coated in silicate minerals or even metallic compounds. It was as though the object's outer layer had been scorched and sealed by eons of radiation, a relic hardened by cosmic exposure. But more intriguing still was what this light pattern implied. C2025 V1 might have spent millions of years adrift in deep interstellar space before being captured briefly by the gravity of our Sun. As days turned into weeks, a pattern of coincidences began to emerge. Observations of another object, the enigmatic 3I Atlas, had already stirred debate across the astronomical community. Discovered earlier in the year, the Atlas body exhibited a similarly hyperbolic orbit and an absence of cometary activity. It had been officially classified as interstellar, an unbound visitor from beyond the heliosphere. Now, Borisov's new find appeared to echo it almost perfectly, both in timing and in orbital geometry. Two bodies, two paths, both anomalous, both silent. At the Harvard-Smithsonian Center for Astrophysics, a team led by Dr. Karen Meech and theoretical astrophysicist Avi Loeb began comparing orbital integrations of both objects, searching for a common origin. Their simulations suggested that if projected backward, the two trajectories nearly intersected far beyond the orbit of Neptune, possibly in the distant outskirts of the Oort cloud. Some of the models even hinted at a single ejection event, perhaps a massive gravitational disturbance that hurled debris in opposite directions. The timing was uncertain, possibly hundreds of thousands of years ago, but if true, it would mean that both 3I Atlas and C2025 V1 Borisov were fragments of a larger parent body, a cosmic event frozen in time, and revealed only now, by chance and by the precision of modern observation. Yet not everyone was convinced. Some researchers proposed a more conservative interpretation, that Jupiter, with its immense gravitational pull, might have subtly perturbed an otherwise ordinary comet, tilting its orbit and stretching it into a near hyperbolic path. This explanation, though mathematically sound, failed to account for the absence of a tail or the eerie similarity to Atlas's trajectory. Others considered the possibility of an ancient interstellar object captured temporarily within the Sun's influence, a phenomenon thought possible but exceedingly rare. The last confirmed case, the interstellar asteroid Oumuamua in 2017, had also confounded scientists with its non-sublimating behavior and unexplainable acceleration. Now, history seemed to be repeating itself. Meanwhile, Borisov himself remained characteristically quiet, issuing only a brief statement through the Crimean Astrophysical Observatory. "Objects like these," he said, "remind us how little we understand about the edges of our own home." His team continued nightly observations, assisted by the Rubin Observatory's Legacy Survey of Space and Time, LSST, which provided precise photometric data showing minor fluctuations in brightness, fluctuations that did not match the pattern of rotation expected for a small rocky body. Something within C2025 V1 appeared to pulse faintly, as though responding to invisible forces, or to some rhythm far older than our solar system. By early December, data from NASA's NEOWISE infrared telescope revealed that the object emitted an unusually cold thermal signature, colder than any comet observed at a similar distance from the Sun. Its estimated surface temperature was barely 110 kelvins, far below what would allow sublimation of common ices. This, too, challenged explanation. A body traveling through interplanetary space exposed to sunlight should not remain that cold unless its surface composition was extremely reflective or its materials extraordinarily stable. At the same time, the James Webb Space Telescope performed a spectral analysis during its brief alignment window. The results, released to collaborating institutions but not yet to the public, indicated faint absorption features near 3.4 micrometers, a signature potentially consistent with carbon silicate compounds, but also found in certain manufactured materials. Although no one dared to speculate beyond natural explanations, the coincidence of spectral similarity between Atlas and Borisov's new object could not be ignored. Both displayed an excess of carbon dioxide and traces of cyanide radicals, yet virtually no detectable water. In astrophysical terms, that was nearly impossible for a comet formed in the outer solar system, where frozen water dominates all other volatiles. The absence of water suggested something else. Either these were bodies formed in an environment utterly different from our own, or they had undergone transformations so extreme that their primordial signatures were erased. The question of origin became the central theme of every conference in November and December. Some scientists argued for an interstellar explanation. Perhaps these were fragments ejected from a dying planetary system somewhere beyond Alpha Centauri, traveling through space for millions of years before encountering our Sun. Others suggested that we were witnessing the birth of a new category, transitional objects between asteroids and comets, ancient remnants of the Oort cloud long deprived of their volatile content. But as the data continued to accumulate, a more unsettling thought began to surface. The coincidence in time, the matching orbital inclinations, the absence of natural emission, all these patterns hinted at a shared event, perhaps even a shared purpose. Could there be a mechanism still unknown to us that occasionally sends such bodies inward from the solar periphery? A resonance, a gravitational tide triggered by the passage of another star, or perhaps by the unseen mass that many still hypothesize as Planet 9? Mathematical models run at JPL simulated a scenario in which a passing interstellar object, such as Atlas, could gravitationally disturb dormant fragments within the Oort cloud, setting them adrift toward the inner system. If true, Borisov's new discovery would not be an isolated coincidence, but evidence of a cosmic chain reaction, the echo of an ancient interaction between our Sun and the galactic environment around it. The scale of such a process was staggering. Trillions of icy bodies stirred by a passing star's gravity, a celestial ripple extending over tens of thousands of years. Still, the mystery deepened. When cross-referenced with data from radio observatories monitoring the solar system's periphery, astronomers detected faint, low-frequency signals of unknown origin, not communication, but electromagnetic emissions that coincided spatially with the regions where both Atlas and Borisov's object had passed. Though likely natural, these emissions fueled public fascination and speculation. Forums and amateur astronomers began to speak of the twin visitors, while scientists, maintaining caution, intensified their study. On December the 19th, the day of its predicted perihelion passage, C2025 V1 reached its closest point to the Sun. High-resolution imagery from the Soho Solar Observatory captured its approach, a dark speck gliding across the halo of solar plasma, unyielding, silent, indifferent to radiation that would tear lesser bodies apart. In the following hours, as it began to retreat back into the outer system, instruments recorded a minute but measurable non-gravitational acceleration, a subtle deviation from its projected path, directed away from the Sun. The force was small, equivalent to less than 1/10,000th of a meter per second squared, but significant enough to be real. And once again, there was no visible explanation, no tail, no gas, no dust, nothing that could account for propulsion. For those who remembered Oumuamua's behavior 8 years earlier, the resemblance was undeniable. That first interstellar object had also accelerated mysteriously after perihelion, leading to heated debates about its nature. Now, another object was repeating the phenomenon, and this time the discoverer was the same man who had brought us our first glimpse of an interstellar traveler. The parallel felt almost intentional, as though the cosmos was staging a reenactment of its own mystery. By late December, the accumulated evidence painted a portrait both exhilarating and unsettling. C2025 V1 Borisov was an object that defied classification. No cometary activity, an orbit at the edge of solar capture, a cold surface, and an inexplicable drift from its expected trajectory. Whether it originated from the distant Oort cloud or the deep gulf between the stars, it was a messenger from realms we have barely begun to understand. Its discovery, paired with the enigmatic behavior of 3I Atlas, marked what many scientists quietly called the twin anomaly. Two celestial bodies that might share a common genesis beyond the visible limits of the solar system, and somewhere behind the numbers, beyond the graphs and spectrographic data, lingered an unease that could not be expressed in formulas. It was the intuition that perhaps we were not merely observing random visitors, but glimpsing a structure, a rhythm, a sequence, in the vast music of the universe. A reminder that every fragment of rock and ice drifting through the darkness may carry not only matter, but information. That sometimes what appears to be coincidence is the first note of a pattern we have yet to comprehend. In the weeks that followed, Borisov's discovery ceased to be just an astronomical curiosity. It became a focal point of global attention, a mirror reflecting both our scientific precision and our lingering awe. For while telescopes recorded its coordinates and observatories debated its mass, an older human instinct stirred, the sense that something vast and conscious was unfolding in the heavens beyond the reach of explanation, yet calling to us all the same. Long before his name echoed through observatories across the world, Gennady Borisov was a quiet engineer from Crimea, a man who built his own telescopes by hand, grinding mirrors through long nights, guided more by patience than by ambition. In the years when the sky was still something observed only by professionals with multi-million-dollar instruments, Borisov's backyard observatory stood as an act of devotion. It was from this modest dome that in 2019 he glimpsed a faint streak that would later be known as 2I Borisov, the first interstellar comet ever recorded. It was the discovery of a lifetime, yet he treated it not as triumph, but as continuation, as if the universe had simply trusted him with another line of its manuscript. When 6 years later he once again found a body whose motion challenged the sun's dominion, many saw coincidence, but those who knew him understood it as something else, the consequence of a lifetime spent listening to the sky more than speaking to it. The telescope he used for both discoveries was his own creation, a custom-built system with a 50-centimeter aperture and a precisely aligned CCD array calibrated to detect minute variations in luminosity. It was, by professional standards, unassuming, yet its simplicity was part of its power. Where automated systems scanned wide fields in programmed sequences, Borisov watched with human intuition, noticing slight changes that algorithms dismissed as noise. It was this combination of patience and persistence that allowed him to notice the faint signature of C2025 V1 against the dense backdrop of the Milky Way. In that moment, he was not just an observer. He was the instrument through which the universe revealed its next secret. To understand why this second discovery is so extraordinary, one must look beyond the mathematics and into the history of our relationship with the unknown. Since the 17th century, when Newton defined gravity and Kepler mapped planetary motion, the solar system has seemed like a closed clockwork. Predictable, self-contained, governed by elegant laws. Every comet, asteroid, and planet followed a script. But the past decade has shattered that confidence. Oumuamua, 2I Borisov, 3I Atlas, and now C2025 V1. These are not random actors, but new chapters in a story that suggests the cosmos is far less isolated, far more dynamic than our textbooks once promised. Astronomers often speak of the Oort cloud as a mythic frontier, a spherical sea of icy debris surrounding the sun at a distance of up to 100,000 astronomical units. It is from there that long-period comets are believed to emerge, disturbed by the distant gravity of passing stars. Yet C2025 V1 seems to have originated beyond even that frozen sphere. Its computed orbit implies an aphelion, the farthest point from the Sun, so distant that it grazes the galactic tide, where the pull of the Milky Way competes with the Sun's own. To imagine such a region is to imagine near emptiness itself, a place where time moves differently, and where the Sun is only another star among countless others. If Borisov's object truly came from there, then it carries in its structure the memory of interstellar space, a memory written not in words but in isotopes, elements, and the cold silence of cosmic radiation. This is why the object's refusal to behave like a comet is so important. Its silence is not absence but testimony. To remain inert at such proximity to the Sun means that its composition defies the chemistry of known comets. Theories now proliferate in scientific journals. Some propose that its surface is shielded by a layer of refractory minerals, silicates mixed with carbon compounds that trap internal ices beneath an insulating crust. Others suggest an origin within a protoplanetary disk that experienced violent heating, stripping the body of volatiles before it was ejected into space. Still others, more speculative, hint at artificiality, not in the sense of deliberate manufacture, but in the sense of something shaped by processes we do not yet understand, processes that may imitate intention. As telescopes followed the object's retreat from the Sun, another story began to unfold, that of humanity itself. Across observatories, from Chile to Hawaii, scientists felt the same quiet stirring that once drove early astronomers to chart the heavens by hand. They were not merely collecting data, they were witnessing a dialogue between human curiosity and cosmic mystery. The very act of measuring became a form of reverence. In this, Borisov's discovery transcended astronomy. It reminded us that science is not only a method, but also an emotion, a way of feeling wonder without surrendering to superstition. And yet the technical pursuit continues. The Vera Rubin Observatory now tracks C2025 V1 in its slow ascent toward the outer system. Preliminary radar mapping from the Goldstone Deep Space Network suggests the body is roughly 800 meters across, rotating once every 11 hours. Its albedo remains higher than expected, and its motion still deviates minutely from Newtonian prediction. The James Webb Space Telescope will continue spectral analysis throughout the following months, searching for trace gases or energy emissions that could confirm or deny the presence of internal activity. Each dataset brings both clarity and confusion, as though the object resists categorization, demanding that we invent new terms to describe it. There is a poetic symmetry in this moment. The same man who proved that interstellar comets exist has now revealed the possibility that some of them might never truly leave us. In his discoveries lies a metaphor for the human condition, the sense that we, too, are travelers suspended between belonging and exile, moving through a universe that both attracts and releases us. C2025 V1 may one day vanish beyond the heliosphere, fading from view, but the idea it represents will remain, that the boundary between our solar system and the rest of the galaxy is not a wall but a membrane, porous and alive with motion. For the scientific community, this discovery marks a threshold. It demands new frameworks to describe the dynamics of interstellar visitors, new instruments to detect their faint signals, new philosophies to interpret what they mean. Already proposals circulate for dedicated missions, small autonomous probes that could intercept future objects as they approach, gathering direct samples before they vanish again into darkness. Such missions, once theoretical, now feel inevitable. They promise not only to decode the chemistry of these wanderers, but also to answer a question as old as thought itself. How connected is our world to the rest of the cosmos? For Borisov, the question is personal. Those who have met him describe a man who speaks little, preferring the company of stars to crowds. When asked how it feels to have discovered two possibly interstellar objects, he reportedly smiled and said, "The universe leaves footprints. We just have to learn to see them." There is humility in those words, the understanding that discovery is not conquest, but conversation. He represents a lineage that stretches back to Galileo, Herschel, and Lowell, individuals who dared to look longer, to trust their eyes even when the data seemed improbable. The object itself, now receding toward the outer system, carries our attention with it. As it fades, it becomes more than a point of light. It becomes an idea. In the classrooms where children trace its orbit on projection maps, in the observatories where scientists adjust instruments to follow its faint signature, C2025 V1 Borisov becomes a symbol of continuity, of the unbroken thread between wonder and knowledge. It reminds us that even in an age of artificial intelligence and mechanized discovery, one person's gaze, guided by patience and curiosity, can still change our understanding of existence. If future missions confirm that Borisov's object is bound after all, an ancient child of our own system sent wandering into the dark, then we will have touched the edge of our own origins. If, on the other hand, it is truly interstellar, if it comes from another sun, another time, then we are witnessing a message from across the galaxy, a fragment of matter carrying the memory of worlds we have never seen. Either way, the result is the same. The universe is speaking, and we are listening. In the years to come, when the object disappears beyond the reach of our telescopes, astronomers will still trace its path, recalculating its position in simulations, replaying the geometry of its journey. Somewhere, in a future century, it may pass near another star, its orbit briefly disturbed once more, beginning the same cycle again. And perhaps, on some distant world, another observer, alien or human, will see it drift across their sky, a faint glimmer carrying our sun's light, and wonder, just as we do now, where it came from. The story of C2025 V1 Borisov is not merely the story of a celestial object. It is the story of how the universe reveals itself. Slowly, enigmatically, through patterns that at first seem accidental and later inevitable. It is the story of a man whose persistence turned coincidence into revelation. And it is the story of us standing at the edge of our understanding, realizing that the sky is not silent, only subtle. As the final data sets arrive and the object fades into the cold, one truth remains. Discoveries like this do not end. They echo. They echo in equations, in imagination, in every telescope turned toward the dark. For beyond the numbers and models, beyond the reports and the cautious language of science, there lies something older. A quiet recognition that the universe has always been whispering. We are only just beginning to listen closely enough to hear.